The purpose of this lab is to visualize how a rolling object compares in real life and simulation, and compare the two models in order to explore the principles of Newton's second law and the momentum principle. The first model is a rolling object that was tracked through an online program. The second model is a glow script code that was modified to simulate the computational data from the object rolling. The observational data from the object tracker and the theoretical data from the glow script code provided similar progression of distance over time. This resulted in almost a perfectly linear graphs of time versus position for both models. This indicates constant velocity, and the computational model supported what happened in the real-life experiment. So the main physics ideas in this lab are Newton's second law and the momentum principle. Both of these concepts go hand in hand. Newton's second law states that force equals mass times acceleration, and the momentum principle states that the net force is equal to the rate of change from momentum. In the lab, the object is pushed once and rolls at constant velocity. This is because there are no external forces, resulting in a net force of zero, no acceleration, as well as no change in momentum. Therefore, momentum is conserved according to Newton's second law and the momentum principle. This theory was supported by the experiment and the data. In addition, the position update equation was used to determine the average velocity of the experiment, which was then put into the glow script code and turned into a simulation. The tracker observational data provided real-life evidence to support the findings of the lab. The system was the rolling object and the surroundings were the table. A ruler was placed behind the rolling object to show how far the object rolls in the video. In both models, the initial condition was an object at rest being pushed by an external force. Both models had the same initial conditions and velocity. However, one model is observational and the other is computational. This is a video of the experimental model. In this video, there are 22 data points with 0.333 seconds in between. The computational model is shown here as a glow script code. This illustrates the experiment if there were no errors and external factors affecting the system. The glow script code for this model does three tasks. It creates a visualization of the vector of the lab, graphs the position versus time and velocity versus time, and finally the position of the rolling object every 0.333 seconds. As you can see, the data from the experimental tracker model was you put into the position update formula, and an average velocity was found and put in to the code, which resulted in these images, which is the visualization, the graphs of the data, as well as the position versus time data for all data points. This is the data extracted from both models put into seconds versus meters, illustrating a linear graph for both, which indicates constant velocity. Two questions in this lab is if the axes were flipped, what would happen? The velocity would be the same, but negative. However, this does not impact the findings of the data. Another question is how many forces result in the net force of zero in the simulation? There are two main forces, gravity, which pulls the object downward, and the normal force, which pushes the object upward from the table. In conclusion, the similarities are the graphs as they are both linear, going positive, and differences are the slight variation of data points. Some possible sources of error are uneven surfaces, uneven force being put onto the object, as well as friction. In conclusion, this lab reveals that the tracker data behaved as expected by having a linear data indicating a constant velocity in the experiment. The simulation data supports this because the experiment behaved similarly to the simulation. This also supports the principles of Newton's second law as there are no net forces, therefore no acceleration, resulting in the constant velocity shown in both graphs.